Hello everyone, my name is Paul James and my colleague is Mercy, and we are here to present our project Cropintel CAS, technically known as contrastive attention-based knowledge distillation for coffee yield prediction using capsule neural networks. As we all know, coffee is has been one of Uganda's largely exported crops. And as we can see from the statistics here, it actually brought in a lot of money. And basing on where coffee is grown in Uganda, those are the regions mapped Arabica for red and Robusta for blue. And let's give an example. There is Chagalanyi, who is coffee limited farmers, who actually goes to buy coffee from local farmers and processes them, sells them to the end users. And the method that they used to use to calculate the amount of coffee that they will yield from a particular tree or from the coffee plantation was extrapolation, uh, coffee yield estimation, which was ineffective and it lacked standardization. That is why we came in with our project using now computer vision to directly predict the amount of coffee that we shall get from there. Well, how did we do our project objectives? We have actually trained models with at least 75% accuracy to predict coffee yield based on the coffee plant images that are being provided to it or fed to it. And it will give us real time in this case, and we actually develop a user-friendly interface. As we can see there, we provided an image, then the results, and converts them to kilograms. And it is going to we have also improved the accuracy and interpretability using explainable AI techniques like LIME and other techniques. And well, let's go to solution overview. Our solution overview, we use an external or public data set. Then we process the public data set, converted it to RoboFlow net, darknet. Then we used it to train our models. Here, when we talk of the data we have classes, which is unripe, ripening, ripe, and then coffee trees. Then the annotation instances are being shown there for all the images that we actually annotated. And then we make sure that all the images are size 10 MBs to 15 MBs. That means it is going to be a high quality image with the dimensions as we are seeing there, and then the resolution beginning with 72 up to 300. And then we collected data. Then we also added our partial annotation, as I told you, using Protocol. We use public, but we added our partial annotations. We added some annotation to it. Then we clean it by removing the duplicate and blurry images. And then we use the data argumentation image data generator. So that is the RoboFlow that we have used. And then we actually add to test it so that we find out the trained images, valid images, and test images, as we are seeing from the graph. And apart from that, well, our models, we have trained a lot of models, that is regression plus attention-based models. What we first did was this: when we got our data sets, we trained what we call YOLO V8 model, and then we use YOLO V8 to train most of these models, that is on the regression model, and then attention plus regression model, and capsule model, then plus other models. Well, our base model was regression model, and then that is what we use to predict with the accuracy of the 0.756. Well, our system architecture shows us here, we have the training part and then the testing part. Our training part is simple. We just loaded data, extracted the features in terms of ripe, semi-ripe, unripe, and ripening. And then from there, we had to use those features to train our models directly by identifying those features. And then we evaluated by also feeding in some image during the training to see, after the training, it also detected the image and then evaluated immediately to see our results. Now the testing period. Here, it is going to do the exact same thing, extract images and extract images, then it predicts using the model and then evaluates them. And then, well, in our next page, we are going to use some of the implementation details. The language that we have used is Python. for creating or generating training, or this one with the libraries of TensorFlow, Opens Computer Vision, then Metaplot, and then some explainable AI like Lime, which is local interpretable model agnostic explanation. And then we use APIs like Flask and UI, which was developed using HTML and other stuff. The platforms we use are Google Colabs and among other platforms. Thank you. Let me invite my colleague to proceed from there.
Hello, everyone. My name is Massimo Wanguzi. So I'm going to ask you to zoom out of that picture, of that technical bit, and look at the bigger picture. Before we came to a conclusion of our base model, we looked at the results from the different models, where we have the attention-based model results and the CNN model results and the support vector machine result. And as we can see, our attention-based graphs are more promising. So what is the significant impact of our project is food security. And through food security, we are contributing to zero hunger, which is SDG 2. And our product does not just end on the yield numbers. It's a catalyst for digital skills for the farmers. And it also contributes to the industry of Uganda and the innovation for Uganda. Our product presents a novel idea of attention based with yellow V8 and CNN. And it also uses a formula that is novel. Some of the copyrighted assets we use include Flask API, HTML, UI, the UI design, and we hope our trademark Cropintel CAS TM can be licensed. How we plan to make money from this project is through premium model, where farmers will have a period to try out the platform. Then subscription, farmers will be expected to pay 50,000 and cooperatives will be expected to pay 500,000. Then government contracts, and then licensing to different coffee processors and exporters. And we also plan to partner with different companies. Those are the coffee, different cooperatives, and some of the technology companies to be able to bring this product to market. Our market size is a total of 846 million. Those are all the coffee farmers in Uganda. And from this, we can attain 68 million USD as our attainable market. And from this market, we are sure that 5 million of these people, we are sure that 5 USD million value is going to be obtained. We plan to start with 500 farmers and then expand to the different regions in the country. And with time, we expect our neighbors to adapt to our system. And after that, we hope to expand to the different crops. This is a snapshot of our system. On the left-hand side, the user is being prompted to input the image of their coffee plant. On the right-hand side, we are seeing results showing the overripe, ripe, semi-ripe, unripe, and showing how much the coffee tree is going to produce at the end of the harvesting period. These are the different roles that we played in order to bring this project to life. My teammate was in charge of the UI design, the modern model training and techniques and their evaluation, the data pre-processing, the model deployment. I was in charge of the documentation, dataset collection, training using the traditional methods and their evaluation. We have learned that implementation of explainable AI is very important, and also we need an expert in the domain to be able to tell us if the aspects we are using to determine the yield is right, and also that offline functionality is very needed because not all areas in the country are able to receive the internet. And it's always good that we train our models with new data sets to reduce the biases. Some of the challenges we face include the data inconsistency, the computational resource limitation, the limited data availability. What we plan to do includes implementing IoT-based sensors for real-time analysis, regional training workshops, and incorporating drone-captured multispectral image to reduce on the burden of taking a picture of each plant and also expand our product to other crops. With Cropintel Cast, we hope to reduce the workload by 20 plus hours and hope to reduce the resources that the farmers use to be able to predict their yields and improve the agriculture sector in Uganda. Thank you.